Okay, good day guys. Welcome to a lesson on factorization. I will be using the use of manipulatives to explain what factorization is in the most simple form. Okay, so what I have with me is some nails and some plugs. Now, what I am going to do, I'm going to take these nails and plugs and basically put them in groups so that I can package them. Right, so I'm going to take the nails, I'm going to take some plugs, I'm going to put them in groups, right, so I can package them. Now each of the group each group should have the same contents. So basically, if I take, let's say, one nail and one plug and I put them together, right, all my other groups should have one nail and one plug. I cannot have a case where I have two nails and two plugs. Okay, so I want to put them in groups, but each group should have the same contents. And not only that, there should be there shouldn't be any nail or any plug remaining. All the nails and all the plugs should be in a group. They shouldn't have anything remaining. Okay, so let's see. So let me start by counting how many nails I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So we have 10 nails, and then we have 1, 2, 3, 4, 5 plugs. Okay, so as you can see, we have 10 nails and 5 plugs. But as I said in a previous video, mathematicians are lazy, so we do not like to write a lot. So we're going to say that N represents nails and P represents plugs. So in a reduced mathematical form, we basically say we have 10 nails and 5 plugs, right? Now we want to put these in groups. Okay, so now let's go back to our manipulatives here. We want to put them in groups, right? Okay, so let me see. You have 10 nails and 5 plugs. Let me see. If I put one nail with one plug, will that be sufficient? Okay. First of all, I said that yes, each of them should have the same content, but they shouldn't have any nails remaining, right? So let me see if I just add the remaining nails to each group. Okay, we did it. Right? We have 10 nails and 5 plugs. 10 nails and 5 plugs, and now we place them in groups. How many groups do we have now? 1, 2, 3, 4, 5. Now, what does each group contain? Each group has 2 nails and 1 plug. Each group has 2 nails and 1 plug. So, okay, so originally we just had the 10 nails and we had the 5 plugs, just like that. But now, after we have grouped it, we realize that we have 5 groups, 5 groups that we'll package soon, right? And each group contains 2 nails and 1 plug. I can put the 1 there, but we know we don't really have to put ones in front of our variables, because 1 times anything is itself. So originally we had 10 nails and 5 plugs. Now when you group it to be package, what we realize is that we made 5 packages, right? Remember our brackets represent our packages, and within each package we have 2 nails and a plug. 2 nails and a plug. So 10n plus 5p is the same as 5 by brackets 2n plus p. Now this is factorization. Let us do another scenario. Okay, so now we have another set of nails and plugs, right? Now, in order to make this video shorter, I've already counted the number of nails and the number of plugs beforehand. So this is 6 plugs. We have 6 plugs there. And we have 24 nails here. 24 nails. Okay, so we have 24 nails and 6 plugs. That's the same as saying 6 plugs and 24 nails. Now we want to put these in groups and packages. Okay, now let's analyze our task. Let's analyze what we're going to what we have to do. First of all, we have to take our nails and plugs, and then we have to share them into individual groups. Now, what mathematical concept deals with sharing? In fact, what operation do we typically use when we hear the word share? Now, if it doesn't come to your mind, that operation is division. Divide. When we divide, we are essentially sharing. Okay, so that's one thing. We are sharing these nails and plugs and we're putting them in groups, right? Now, the other thing, we need to share it in such a way that there are no nails and no plugs remaining. We shouldn't have any remainder, and it should be shared. Top of that, each group should have the same contents. Okay, so we're dividing, yes, because we're sharing, but we're dividing by a number such that when we divide by the number, there is no remainder. What do we refer to that number as? What number, when you divide it by another number, you do not get a remainder? What is the name given to that number? Think. I'm giving you 5 seconds to think. 1, 2, 3, 4, 5. Okay. So if your answer is factor, that is correct, because the factor of a number is the number that divides another number without a remainder. Okay. So what does that mean? Let us look at our scenario there. We have 24 nails and 6 plugs. Let us write that in mathematical form. Okay, so we have here 24 nails and 6 plugs, right? Now, the number of groups that we are going to share our 24 nails and 6 plugs into should be able to divide 24 and 6. So it should be a factor of 24 and 6 such that they can divide each other without a remainder. So what is that? We are looking for the common factors of 24 and 6, right? So what are the common factors of 24 and 6? Let's look. Factors of 24. Okay, so we are dividing 24 nails and 6 plugs into groups such that we have no remainder. So we know that we are going to use the factors of 24 and 6, but not only the factors, but the common factors, right? So now these are the factors of 24 and these are the factors of 6. Let us identify the common factors between 24 and 6. So 1 is a common factor, 2 is a common factor, 3 is a common factor, and finally 6 is a common factor. Now we're going to focus on all of them, but want to pay the most attention to 6. We'll see why in a moment. Okay, so back to our nails and plugs, right? So we said that the common factors of 24 and 6 are 1, 2, 3, and 6. So let us see. How will that help us to group these things easier? Okay, so if 1 is a common factor, when you divide 24 into one group, that's just 24 in one group, right? And when you divide 6 into one group, that's just 6 into one group. So we can package them as 1, right? Simple as that. Okay. The next scenario, we said that 2 is a common factor of 24 and 12. And 6, right? 2 is a common factor of 24 and 6. So what that means is that we can divide 24 into 2 groups. So that's 1, 2, when you divide 24 by 2, you get 12, right? No remainder. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, missing 2 more, 11, 12, right? So this is 12 and this is 12. Now, when we divide 6 into 2 groups, we have this, right? So 3 there and 3 there. 6 divided by 2 is 3. So we're going to put 12 nails and 3 plugs in one package. We can package this, and then another 12 nails and another 3 plugs. So now we have 2 groups. Remember, 2 was our common factor, 2 groups. And now each group contains 12 nails and 3 plugs. 12 nails, 3 plugs. Let us see how we write that mathematically. Okay, so these are our common factors. Mathematically, when our common factor was 1, 24 nails and 6 plugs is the same as having one group where that group contains 24 nails and 6 plugs. That's obvious, right? Okay, so we use our second common factor, which is 2. Now, we say that 24 nails plus and 6 plugs is the same as having 2 groups, as I showed you earlier, where each group contains 12 nails and 3 plugs. This is it there. We have 2 groups and each group contains 12 nails and 3 plugs. Each group contains that, right? So we can share it like this. Let's try the other common factors. The next one was 3. Okay, so our next common factor was 3. So basically, we are going to divide these into 3 groups. We're going to do the nails first, and then we're going to go into the plugs. Right? So 24 divided by 3 is 8. 24 divided by 3 is 8. So 8 there, no remainder. So we have another, Let's see. We have another 8 there, and we have our final 8. So we have 3 groups of 8. 3 groups of 8 is 24. Now, 6 divided by 3 is 2, right? So we have 3 groups of 2. 3 groups of 2 is 6, right? So you're going to take our 8 nails, and you're going to put them. So that's one package that we can package and sell. And then we can take our other one, put in another package. Let me see, we can see it. Okay. And then we can take our final one and put it in a other package, right? So now we have 3 packages, and each package have the same content. We have no more nails and no other plugs left over, right? We shared it equally without any remainder, correct? Okay. So 24 nails and 6 plugs can be written as 3 groups, where each group or each package contains 8 nails and 2 plugs. Let us look at that mathematically. Okay, we'll not look at it mathematically yet. Let us do the final one. Let's do the final one. The final common factor, which is 6. Okay, so our last common factor between 24 and 6 was 6. Now, not only is 6 a common factor, but it has a special name because it's the biggest common factor between the two numbers. So we call the biggest common factor, or the number that's the factor that has the highest value, the highest common factor. Okay, now this we said that when I said that, I wanted to focus on this the highest common factor. Okay, now since 6 is our highest common factor, we are going to divide 24 into 6 groups, right? So when you divide 24 by 6, you get 4. So if you want to know how many nails each group contains, that's 24 divided by 6, which is 4. So you put these together. All right. So now we have 6 groups of 4. 6 groups of 4 comes up to 24, right? Okay. Now we are dividing our 6 plugs into 6 groups. So how many groups can we divide 6 into? Sorry. How many plugs will you have if you divide them by 6? 6 divided by 6 is 1. 6 divided by 6 is 1. Let me put them properly. So that's 1 group, 2 groups, 3 groups, 4 groups, 5 groups, and 6 groups, right? So 1, 2, 3, 4, 5, 6. 1, 2, 3. Let's see. Put it there. 1, 2, 3, 4, 5, 6. Okay. So now, when you divide our 24 nails and 6 plugs into 6 groups now, basically put them together, the 6 groups, so that we can package. Each group now will have 4 nails and 1 plug. Each of them must have 4 nails and 1 plug, right? When you divide 24 nails and 6 plugs into 6 groups, each group will have 4 nails and 1 plug. Okay, so now let us look at this mathematically. Okay, so mathematically, we didn't do the one with the 3 before. So if you divide in 24 nails and 6 plugs into groups, we found the common factors, and the common factor in this case was 3, right? So that's 3 groups, and each group will contain 8 nails and 2 plugs. When we divided it into 6 groups, our 24 nails and 6 plugs into 6 groups, each group will contain 4 nails and 1 plug, right? But now we said that we are going to focus on this number there, 6, simply because 6 is our highest common factor between 24 and 6. So the highest common factor of 24 and 6 is 6. Okay. Now the reason when you're factorizing, right, you should always go for the highest common factor. Yes, you can write it like this, right? You can write it like this. But when you're factorizing, always go for the highest common factor. Think of it like that. Let's say you are a retail seller, right? And then you basically buying your plugs and your nails and you're selling it retail. You're not selling wholesale, you're selling retail. You know, retail sells small packages when wholesale sells big packages, right? So because you want to make profit, instead of packaging them big, you package them small, because generally the smaller things are less cost effective than the bigger things. For example, what example can I give? Let's say a small tin of milk that is a third of the volume of a big tin of milk costs, let's say, 150, right? It's a third. So for it to make up the same volume as a big tin of milk, you have to buy 3. But if you buy 3 of the small tins, then 3 times 150 is 450. But the big tin of milk is not 450, it's $3, right? The same concept. When people package things in a smaller packages, it's generally less cost effective, and it's more cost effective to buy bigger things. So that's how retailers make profit, by putting them in a smaller thing and jacking up the price a bit. That's how they make profit, retailers. So basically, we are retailers and we want to make as much profit as possible. So instead of sharing our thing into a small number of groups, we want to share it into a big number of groups, right? The biggest number of groups that we can possibly use. And in order to find the biggest number of groups, obviously that will be our highest common factor, because actually the number that goes there is the highest common factor. Okay, so I'm going to bring out the last set of nail and plugs, right? We have our last set. This time we want to put these in groups. So as we know, we're going to count our nails first. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 nails. We're going to count our plugs. 1, 2, 3, 4, 5, 6. Okay. Now we want to put them in groups, but we do not want any remaining, and we want to have the most number of groups that we possibly can have. Okay, so now we already know that we are going to use factors. So let us use factors on our paper in a mathematical form. Okay, so as we said previously, we had 9 nails and 6 plugs, right? And we're going to put these in groups. Now, we are going to look at the factors of 9 and the factors of 6. So the factors of 9 are 1, 3, and 9. We don't put 3 two times when you write it like this. And the factors of 6 are 1, 2, 3, and 6. Okay, so our common factors between 9 and 6, our common factors are 1 and 3. But as we said, we want to focus on the highest common factor, which is 3. So the HCF, the highest common factor, is 3, right? Okay, so we're going to write 9 nails and we're going to put 9 nails and 6 plugs into 3 groups. Now, you're going to divide the 9 nails and the 6 plugs in 3 groups. So, if you want to know how many nails each group will contain, obviously we're going to divide the 9 by 3. 9 nails into 3 groups. Each group will contain 3 nails. Alright? And now 6 plugs into 3 groups. Each group will contain 2 plugs. So we can write 9 nails and 6 plugs. We can put them into 3 groups where each group contains 3 nails and 2 plugs. So generally when you're factorizing, the most important thing is to find the highest common factor between the 2 terms, these 2 terms there. After we found the highest common factor, we put it on the outside of the brackets, and then to find what goes inside of the brackets, we divide our terms by our highest common factor. So for example, if I give you 12x plus, let's say 18y, we look at the highest common factor of 12 and 18. The highest common factor of 12 and 18 is 6, right? So now 12x into 6 groups is 2x, 2 xylophones or whatever you want to call it. You can even pretend that x is actually another letter like p. You can just, or n. So you can pretend that x represents nails because x can be anything, x is a variable, right? So 12 nails, we're dividing it into 6 groups. So we're having 2 nails in each group. And now 18 plugs, we're dividing it into 6 groups. We will have 3 plugs, right? So 12x plus 6 plus 18y is equal to 6 by 2x plus 3y. Now let's say we had 12x plus 18y plus let me see. Okay, plus 9z. Same thing. But this time we have to look for the highest common factor of these 3 terms. So the highest common factor of 12, highest common factor of 18 and 9 is 3. Right? So 12x divided by 3 is 4x. 18y divided by 3 is 6y. 9z divided by 3 is 3z. 3 groups where each group contains 4x, 6y, and 3z. Or 4 nails, 6 plugs, and probably 3 screws. Right? 12 nails, 18 plugs, 9 screws will be 3 groups where each group contains 4 nails, 6 plugs, and 3 screws. This is factorization. This is the power of mathematics. Mathematics is everywhere. You just have to find it. You just need to understand how it's presented to you. Thank you.